Till our previous video, we saw the difference between all the three join, where we discussed if we need the maximum speed, go for broadcast join, perfect for joining a small dimension and a table under 10 MB to the fact table. No shuffle, no sorting. Just watch that out of memory error if that two table size is big. If you need the greater speed and you have the big tables, go for the shuffle hash join. Great for tables join which are relatively smaller. It repartition the data with no sorting needed. Make it the second fastest option. The third one was sort merge join, where when you are dealing with a massive data set on both the sides, that is Spark heavy lifter, it's sorted and merges efficiently without blowing up your memory. So in continuation to that, next video.
Hey YouTube world, welcome back to another video. So in this video, we are going to discuss about Spark SQL Engine. Why this Spark SQL Engine is required? Because this is the thing when you write your code, how the code will go through the complete life cycle till the billing documentation which you have created for your client. And with the interview perspective as well, this is a very important question. They directly ask you how Spark evaluate your SQL, how it help in optimizing, how actually SQL is evaluated in Spark. These kind of questions they will mix you, and believe me, this question was asked to me by Tech Mahindra. So this is literally a good question. So pay attention to it. Okay, let's get started. So let's say you are a developer, okay, and you are developing any kind of code. So you are here, okay, and this is you, and you have created some kind of code, any kind of code. We can make it as any kind of code. So let's suppose Python notebook you have created. Okay. So this is your Python notebook. So you have created your Python code, something like this. Okay. So what happened here is you have written something inside this Python. Okay. And let's suppose not Python, you have written something in SQL format, or even if it is a Python SQL notebook, right? You might have written SQL inside it, possible, right? So this is not our concern right now. What you have written, what you have not written. Let's put it inside our block. Okay. So let's put inside this. So this is your code. Now what happened here is you have done your job. This is your job and you have done it. Now it's the thing is Spark has to do something for you, right? So what Spark will do, now let's come to it. Okay, let me shift it over here. So as soon as you have written this, right? So your code will be converted to the plan. Till now, we are already clear with that approach as well, right? It will be created as a plan. Okay. So what sort of plan it will be? It should be, let's say, it will be an unresolved logical plan. Okay. And we know that plans are not directly executed. So basically, it's a plan for you. Okay. So developer has written the code, come to your code, and the code will be converted into a plan. So this is your plan over here. Okay. This is your plan. Now, what happened to this plan? This is the important thing now. Okay. As soon as the plan has been created, this plan will be now resolved to something very important. And that important thing is, I will mark it as blue color. And this thing over here, it will be called as like your resolved logical plan. Getting this resolved logical plan, right? Something happened very interestingly here itself in between of it. So this is the process which I want to discuss with you right now. So here in between, something has happened. What is that thing? Let me zoom it a bit here now. Okay. So something has happened here. We have already seen we have created a catalog, right? We created a catalog, correct? Catalog, CATALOG. We created a catalog. And you know what this catalog contain? It basically contain your table name, okay, your column name, and it will also contain your database name, and everything like, and even the catalog. We have created the catalog. Remember the volume catalog? We have created Databricks learning catalog. So catalog name as well, CATALOG, catalog name. So what this unresolved logical plan contain? This contain all the code which you have taken, right? You might have taken any column here in the SQL which you want to perform any aggregation, something like that, right? So this unresolved logical plan will be like checked against this catalog, which we have this catalog, okay? And this catalog have all these things inside of table name, column name, database name, catalog name. So it will check each and every column. Let's suppose if there is a column as categories, okay? table has the product of PRO, DUCT product table, and it has the column as category, CATEGORIES. Mark this categories I am saying over here, categories. Okay. But somehow by mistake, you have taken in your code category as a name. In this code, the Python code which we have created, you have kept it as a category. CATOGRY, category. So definitely it is going to throw error, right? So from where this error has to be created, it has to check over here, the catalog itself. So this is something which will give you an analysis error. As soon as you hit any analysis exception, so this is the guy who is throwing it. Remember this, mark this, note down it in your notes, wherever you want to note it down, mark it, analysis, ANALYSIS, exception, EXCEPTIR. Understood? So this is the place where your analysis exception is going to throw out. So now analysis exception has been thrown out. You have to resolve it. And again, you have came back. The plan has been created for you and it has checked against the logic catalog. It has done its analysis over the plan and it has created the resolved logical plan. Okay. It has passed the situation and it has created the logical plan now. Going forward, now this resolved logical plan is something not where Spark is going to, stop. It has to do some other thing as well. Now the things come into the picture. Now it will go for something very, very unusual, which we have not unusual. I will say it's very good thing about the Spark is it will give us something which we will call as optimization. Optimization. This optimization logical plan Spark is going to create for us now. Okay, so can you see a single plan has been converted to resolve logical plan, then the optimized plan. This is called the optimized plan. Okay, this will be a optimized plan. What happened here? Any empty partition will be coalesced together. Any if Spark feel there should be a query pushed down, it will do it. And if Spark feel the data is huge, we have already seen in plan, right? The query execution plan. It has already limited data for us. Perform here. So everything will be performed here. Photon will come into the picture. PHO31 Photon will come into the picture. Then there is a AQE if it is enabled. We will discuss AQE later on. But these are the things which happen here. These are the things which usually take place here. You can note it down. This as well. So optimization plan run over the Photon, AQE, and even query optimizer, which is Spark providers. All the optimization thing will be done here. Now, after that, the physical plan came into the picture. Okay. So your physical plan will come into the picture. This is your physical plan. We'll call it as Control C, Control V over here. PHYSICL, physical plan. PLAN. Okay. So what this plan is, this is the like final of your plan. You have written your ugly code. Sorry to say, but we don't write very efficient code, right? You are aware of that. So you have written your ugly code. Spark has optimized it and it has created the physical plan for you. This is the place where execution is now going to take place. Okay, physical plan has been created. Now after that, different things come into the picture. This is not necessarily required, but this is an extra information for you. After that, there will be something called as a cost model. Okay, your cost models, USD cost model, MOD. Yeah. So what this cost model will do? This cost model is something like how much resources it has taken, how much USD it has taken to execute your this unresolved logical plan to a physical plan, how much cost it has acquired. And after that, a complete set of things has been done. So this is something which you don't need to know right now, cost model. Okay. And so this is how your Spark SQL engine works. Okay. So there are the phases inside it. Let me zoom out a bit. This is too much. Okay. This looks good for me. So what happened is, let's do a quick revision over it. You are the developer. You have created your code. It will go to a plan. It will be created as an unresolved logical plan. Okay. And unresolved logical plan will be a check against our analysis will be done against our catalog where our table, column name, database, everything has been put here. If you put any wrong column name, which is not present in the catalog, it is going to throw an analysis exception for you. You have to correct your code, and then it will again check with the catalog. When it passes, it will create a resolved logical plan for you. After a resolved logical plan has been created, optimization will come into the picture where AQE and Photon, any query optimization which Spark provide, or if you have taken build it by your own, you can provide it here is itself. Okay. And after that, a physical plan will be created. This is the plan which we actually saw in our partition in recollays and repartitioning foliays. Everywhere I saw you a physical plan, right? So that was this, the physical plan which we are able to show it. Okay. And after that, Spark has executed it and things go smoothly. So this is the complete Spark SQL engine. This is how SQL is evaluated inside our Databricks environment, because Databricks, it is a kind of a layer over Spark. And as soon as this has been created, your Spark SQL will run and it will give you a result. Okay. So this was the whole video about. Hopefully you have liked the video. I have cleared the, uh, you know, uh, this topic to you very clearly. And if you like the video, please subscribe the channel, as this will really help me lots to make more, premium content like this for free in YouTube, and help me grow, help you grow. Let's build a community together as a data engineer toward you, maybe whoever downstream as well, data scientist and all. So let's grow together, and hopefully you like the video. If you have liked the video, please do write your lovely comments for me. It will be very helpful. Okay, see you in the next video. Thank you.